Okay, so what if the biggest threat to a multi-million-dollar manufacturing plant isn't some huge power failure or a broken machine, but a simple mistake on the blueprint? Well, that's exactly what we're digging into today. We're talking about cleanroom design, where things you can't even see, like layout and airflow, are the absolute guardians of product safety.
And this quote, well, it really gets to the heart of the problem. See, the most expensive mistakes in building a clean room are often completely silent. They're like a little time bomb, hidden right in the design from day one. Let's actually look at a real-world story to see what I mean. So I want you to picture this: a brand new, multi-million-dollar pharmaceutical facility. The floors are gleaming, all of the equipment is shiny and state-of-the-art, and the HVAC system, the air conditioning, it's this massive beast. On the surface, it looks like the perfect clean room. But as you can probably guess, looks can be, well, pretty deceiving. Yep, that perfect image, it shattered fast. Within just a few months, the clean room was failing one validation test after another. The particle counts in the air were just way too high. And the crazy part? It wasn't the equipment's fault. The problem was way more fundamental. It was the blueprint itself. The layout was literally forcing people to cross-contaminate their own workspace. And this right here shows you that exact mistake. See, way too often people think of a clean room as just a construction job. You build the walls, you stick in a big AC unit, and you hope for the best. But that's not how it works. A real clean room is an engineering project. It starts by understanding the process inside out, mapping every single step people and materials take, and then engineering a perfectly controlled environment around that flow.
So that brings us to our first pillar, layout planning. And honestly, this is less about architecture and more about choreography. You're designing a very specific dance inside the facility, making sure that the paths for clean materials and the paths for waste never, ever cross. If you get this right, you've built the foundation for everything else.
Okay, next up is airflow engineering. Now, if the layout is the stage, then the airflow is the absolute star of the show. Think of it as a constant, invisible cleaning crew that's always working, actively grabbing contaminants out of the air before they even have a chance to settle on anything critical. Then our third pillar is something called the pressure cascade. This is basically an invisible force field for your clean room. By making tiny adjustments to the air pressure in each room, you create this one-way street for air. It's like a gentle river that's always flowing away from your cleanest areas, carrying any potential contaminants with it. And finally, we have contamination barriers and compliance. This is where the physical stuff, the nuts and bolts, meets the rule book. We're talking about everything from the special airtight doors and sealed wall panels to the big, complicated standards like ISO 14644 that make sure the cleanroom isn't just working well, but is also totally legal and compliant. So how do you actually put a layout like this together? Well, it's all about zoning. You could think of it like a castle, right? You've got all these layers of defense protecting the most important area. Right at the core, you have Grade A, or ISO 5. That's the super sterile zone where the most critical work happens. And then each grade around it, B, C, and D, acts like another protective wall, getting a little less strict as you move away from the center. Okay, so let's break down the two main tools an airflow engineer has. For those super critical Grade A zones, you use what's called unidirectional flow. It's like a powerful, invisible sheet of air that is constantly sweeping particles down and away. But for the less sensitive areas, you can use turbulent flow. This is more like having a bunch of fans mixing the air around, which helps to dilute any contaminants that pop up. And just to give you a sense of the sheer power we're talking about, check out these numbers. In an ISO 8 room, all the air gets replaced every couple of minutes. But in an ISO 5 clean room, we're talking about replacing all of the air in the entire room every 7 to 15 seconds. I mean, the amount of energy and engineering to make that happen is just staggering. Now, remember that pressure cascade we talked about? That invisible force field? Well, this tiny number is what makes it all work. A pressure difference of just 10 to 15 pascals between rooms. It's so small you'd never feel it, but it's more than enough to create that crucial one-way flow of air, giving you a constant, invisible defense against contamination. Of course, even the most brilliant design is totally useless if it doesn't pass inspection. And as you can see, it's a complicated world out there. You're not just building a clean space, you're building a fortress of compliance that has to satisfy a whole list of groups, from the World Health Organization's Good Manufacturing Practices, or GMP, to FDA rules and other local standards. So how can you make sure design is on the right track? Well, here are a few key questions you should always ask. And the first one, honestly, is the most important. Is this layout designed around the process, or was it just designed to fit nicely in the building? The answer to that one question tells you everything you need to know about the design philosophy.
Your next question gets right to the heart of contamination control. Are the paths for materials, for people, and for waste kept completely separate? Because any overlap, any point where those paths cross, is a massive red flag. That's a built-in risk that you just can't fix later with a bigger filter.
And finally, don't fall for the bigger is better trap when it comes to the HVAC system. A great design isn't just powerful, it's precise. It should be based on careful calculations for things like the heat coming off the equipment and the exact filtration needed. Just getting an oversized unit is a recipe for wasted energy and, believe it or not, poor performance. So if you ask those questions, you'll start to spot the most common design traps, things like rooms that are way too big and just waste energy, or layouts that totally ignore how people actually need the work. But the absolute biggest mistake is thinking a powerful HVAC system can fix a bad layout. It can't. A single door that doesn't seal properly can destroy the entire pressure system.
So, where is all this headed? Well, the future of cleanroom design is all about working smarter, not harder. These facilities use a ton of energy, so the big push right now is for intelligent, energy-efficient designs. We're talking about smart systems that can adapt on the fly, delivering perfect performance while seriously cutting down on operating costs. In the end, it really all boils down to this one simple question. Was this cleanroom designed to just pass a test on day one, or was it designed to actually perform day in and day out? Because just about any design can look good on paper, but only a truly smart design can handle the real world year after year. And that, right there, is the difference between a cleanroom that just works and one that truly excels.